Welcome back to another great interview special, guys. This is the Golden Knowledge Podcast. I'm your host, Pat Foss. Happy Friday. It is Friday, February 18th. Thank you for joining me for this incredible interview. My guest today is theoretical physicist and cosmologist, author of The Physics of Climate Change and A Universe from Nothing. It's Lawrence Krauss. Doctor, how are you?
I'm fine. How are you doing?
Good. I wanted to say for everyone that's wondering, Dr. Krauss has actually been on the show now. This is his third time on the show, and I'm very, very pleased and honored to have him on. Normally, we've talked about things from flat earthers to why is science ignored and why is science great, but this is just a physics episode, period. That is what we're covering today.
Oh, good.
So
good. I hadn't realized I've been on 3 times. That's good.
Three times.
Yeah. Mm-hmm.
So like your Origins podcast, I know you say a lot, you say origins, meaning let's begin at the beginning. So my first question is, what was your journey to become a physicist and cosmologist? What was the journey like for you to reach this point?
It was a long and winding road. I when I was younger, I got interested in science. My mother wanted me to be a doctor and made the mistake of telling me doctors were scientists. And I got interested in science in general. I had a neighbor who was an engineer, and his son was there, and we built models of an atom. But I do remember reading a book about Galileo when I was in grade 11 as part of a course, and that really had a big impact on me. But I had great science teachers too, so I got interested in science, and I thought I wanted to be actually a brain surgeon. And it took me a while eventually to realize, first of all, that doctors weren't scientists, but I also got fascinated by physics, probably because of starting with Galileo, but then reading books by Einstein and George Gamow and people like that, and Isaac Asimov. And then and then I went to some summer science programs, which they had for whatever, I don't know, they call it gifted kids, but good students. My dogs are barking. I'm sorry, they're getting, but and that interest continued. I remembered I read a book by Sir James Jeans called Physics and Philosophy, which was which really had a big impact on me at the time. And then the next book was a book by Richard Feynman, The Character of Physical Law, which really was the book that probably convinced me that science wasn't just all done already, and all the great things hadn't been done already, and that's when I realized that there was possibly a career in science. And but even then it took me a while, because I know it's a long answer to your question, but I wasn't convinced I wanted to do just science. I've always been political. I've always been interested in people and history in particular, and I like Canadian history and actually pursued Canadian history work as well in college. And then eventually, after taking a year off to work on a history book, I finally made the plunge and took it and did a degree in mathematics and one in physics, probably because it was the most interesting degree program at the university. And I didn't expect to continue to do it or get a job. I thought about a Rhodes Scholarship in philosophy, and I happily didn't do that. I went and did my PhD at MIT, and at that time there were no jobs. And so I thought, well, this is fun, but probably drive taxi. And anyway, then fortunately things worked out. So I was always real. I guess throughout the whole thing, I was always fascinated by fundamental ideas, and the excitement that really began with Galileo, the discovery of new moons of Jupiter and the discovery of the laws of nature. Nothing seemed to me to be equally fascinating, and to some extent, it's still true today. I'm still fascinated.
So I do have questions. There are questions from a few fans of mine, a few listeners of mine that are also fans of yours. So the first question is from Tom. He goes by T-Jump on YouTube, has a lot of debates on YouTube as well. But Tom asks, what does space-time emerge from? Is space-time an emergent property? And if so, what does it emerge from?
Well, the answer to that is really simple. We don't know. It's one of the big mysteries. In fact, I'm writing about that in my new book. And so you can wait for that when my new book comes out. But it is one of the big mysteries. Is space-time fundamental, or is it emergent? Does it emerge out of some other concept? In string theories, in some ways, the fundamental objects are string-like objects, excitations that may result in something you observe as space-time. Maybe maybe it emerges out of something else. Some other people think it emerges out of, well, there are lots of ideas, and I won't go into all of them, but I think the main point is that we don't really know, and it really, since space and time are really the purview of general relativity, and general relativity, in order to understand the emergence of space time, we'd have to have a quantum theory of general relativity, a quantum theory of gravity, and string theory purports to be one, but it's not yet a full theory that describes our universe, if it even does describe our universe. And so we don't know the answer, and it's one of the more interesting, outstanding questions. And so, yeah, I think, as you probably know, I say very often that one of the things we have to say more often and be happy to say is that we don't know. And I'm happy to say I don't know, because it means there's things to learn.
So another question I had coming from a friend of mine named Frank. So Frank asks, what is the difference between a scientific version of nothing and a philosophical nothing? Because, of course, your book, right behind me, A Universe from Nothing, confuses a lot of people that come onto my shows or my lives that I conduct, which is called Ask an Atheist. So I have those, and a lot of people say, well, something can't come from nothing, right? I used to have a lot of theists say that to me. So I'm wondering, what is the answer to that question? What is the difference there, and what do you mean?
Well, look, I think the point is that the scientific nothingness in science, like all things in science, is well defined, and it's also malleable. As we learn new things, the idea can change. I think ultimately there should be no difference between a scientific nothing and a philosophical nothing, because philosophy derives from science. Philosophy, to make any sense, derives from empirical evidence. And so there's a lot of confusion, and people like to say a lot of things about my book who haven't read it. But the question is, when you say nothing, there's many different versions of nothing, and you have to be clear about what you're talking about. And the kind of nothing that I think is really important is that our universe, the space and time that we exist in, did that always exist? And if that didn't exist, then there was no space and no time and no particles and anything else. But you can also ask, were the laws that govern our universe around before then? And that's an interesting question. But you can imagine the laws being eternal, but space and time popping into existence, and because of those laws, and so when I say nothing, I think the best kind of nothing is no space, no time, no particles, no radiation, nothing that we can see or measure in our universe existed. And then our space and time came into existence. And the point is that that's possible, given at least extrapolating the known laws of physics. Now, did the laws come into existence when the universe was created? Or when our universe came into existence? And I don't like to use the word created, but when our universe popped into existence? Maybe, maybe not. It's not a question we can answer. And if those laws pre-existed, you might say, well, what caused those laws? And the answer is, I don't know. But that doesn't mean. But the main thing that's really important, I think, and the real question that religion tries to address and claims that science can't, is the question of how can you have a universe full of stars and galaxies and planets and everything else if there wasn't one to begin with? It appears in common sense that you need some creator to do it. And physics says, no, you don't need a creator to do that. You can create everything we see, even if there was none of that existed at the beginning, and you don't violate the laws of physics. And to me, that's a remarkable statement. Now, you can ask other philosophical or religious questions, but that's the heart of the matter. And the heart of the matter is that we can answer in principle that question. At least we can give a plausible answer. Until we have a quantum theory of gravity, we can't give a full answer, but we can explain how it can happen without supernatural shenanigans.
I appreciate that, and I'm sure Frank will absolutely appreciate that answer as well. Another question from Sammy. Sammy says, if the universe finds heat death, if the universe experiences heat death, can black holes evaporate and produce particles that could form a new budding universe?
Well, look, if you're talking about the ultimate heat death, you're talking about the fact that black holes have already evaporated and produced radiation, which is then redshifted away. As long as there's a source of high energy particles or high energy radiation, you're not yet in heat death. But it does, if the universe expands forever, black holes will evaporate, and those particles they produce, sure, there can be local fluctuations that can cause, life forms to exist for a while longer, but the ultimate future is that radiation is going to redshift. And if that happens, so that you basically have a thermal bath with no sinks or sources of energy, then classically, that's it. You can't do anything. Now, quantum fluctuations, if you wait long enough, can always locally produce something that might cause that might allow some local life forms to exist for a while. Quantum fluctuations can happen, but classically, heat death is after black holes have evaporated. So some super advanced civilization, or maybe not super advanced, but in the far future, when there's nothing left than black holes, some life forms that exist out of something, not normal stuff, might exploit the evaporation of black holes as a power source. One can imagine that in principle, even if in practice it's hard to imagine how you do it. But once those black holes have gone poof and there's none left, then I'm afraid the end is rather bleak.
So there's no comforting end. Okay, great, awesome.
No, the end is bad, and that's the way. Now we can't say that with certainty because we don't know that our universe will expand forever, as I've shown in papers I've written. But the likely possibility is it's bad news, and the future is not rosy in the law. And I'm talking about the far future. I'm talking about trillions and trillions and trillions and trillions and trillions and trillions of years into the future, not anything in the near term.
Well, good. I can wipe my brow then, and not worry about my lifetime.
Yeah. There's a cosmology joke that I may have told on your channel before. I don't know, but anyway, I won't tell it now. It doesn't matter. If we had time, I'd tell it.
Abe asks, would it make sense that a possibility of, or at least hypothetically, many worlds theory or hypothesis, could that mean that a possible other you could outlive a current you? So the one that is talking to you right now, the current me that is talking to you, could I die and another me outlive me?
Well, look, it depends which many worlds what you're talking about. If you're talking about the many worlds interpretation of quantum mechanics, which is just a classical kludge, it's not it's a way of classically trying to understand what happens quantum mechanically, but I don't think it's much more than a way to relieve your mind. But a way to try and understand what happens in quantum mechanics classically is to assume that every time you make a measurement, the universe branches, and basically you have, every time you make a measurement, all possible universes exist, and you follow one by your measurement. It's a nice picture that makes some people happy. I don't think it's very profound, and I don't think it's particularly useful. But in that picture, it's certainly possible, if you imagine at every observation, every time you make an observation, that there's a branching point, and you and I are in one, by having this conversation, are experiencing one universe, then one can imagine all sorts of other possibilities. And in all those other possibilities, one can imagine other things happening if it makes you happy. But it's kind of pointless because we live in the universe we measure. Right. And if it makes you feel better to think that there's some version of you that's living in a better or worse universe, go for it.
Another question I had, so now that I realize we're actually early on time, we're good on time right now. So the question I will ask, and again, for anyone that is watching and has just come into the live right now, I am speaking with theoretical physicist and cosmologist, Dr. Lawrence Krauss. We are talking all things physics. We've had a few questions already. So the question now is, with the James Webb Space Telescope launching on Christmas of last year, is there a specific function of the James Webb that you're most looking forward to it performing?
Yeah, I'm most looking forward to being surprised. Its function, all of its functions are interesting. It's designed to look at the first stars that form in the universe, so we can try and understand how stars and galaxies and black holes first formed. Now, that's interesting in itself, but from my perspective, as someone who's interested in fundamental physics, what's most interesting is when we learn about that early formation, we may learn about how dark matter governed the formation of galaxies. And that may give us insights into the nature of dark matter. And also in the nature of formation of early black holes. I think that's fascinating. So that's one of the main functions of the James Webb Space Telescope. The other one that is quite exciting is that it'll be able to, in principle, perhaps image, or at least image spectroscopically, the atmospheres of planets, potentially habitable planets, looking for signatures of life. And that would be incredibly exciting if it discovered them. So those are two of the known purposes of the James Webb Space Telescope, and they're both exciting. But my experience is that every time you open a new window on the universe, you're surprised. And so I'm looking for the things that I don't expect. And that's what's always more fun. So we'll wait and see.
I appreciate that. One of my last questions, it comes from Ewart. Ewart is a very, very good friend of mine who is also very, very scientifically literate and wanted to know from you on your side of things, what in your opinion is the most insightful discovery across the hard sciences to date? And what is your favorite revelation about the mechanics of the universe, if that and most insightful are not one and the same?
Well, anyone who's listened to me on your program or others knows that I don't think hierarchically. I don't tend to have favorites or most exciting. Lots of things are exciting to me, and they're apples and oranges. I think there are one discovery and one potential discovery that I think are profound and important, and that the discovery of the fact that the energy of empty space is not zero, which has taken place in my lifetime, and in some sense I predicted, is profound, because we don't understand at all why empty space should have energy. It doesn't fit in any of our current pictures, and it'll certainly affect and determine the ultimate future of our universe. So it's profound. It's one of the reasons I wrote The Universe from Nothing. And so I think that's a profound discovery that changes everything, but it doesn't give us the answers, which is great. It means it's not all wrapped up. It's still shrouded in mystery and perplexes us, and that's what science is all about. If it was all known, it would be no fun to go into work every day. The other potential discovery, which I think is really quite exciting, is the discovery of gravitational waves. Well, not just the gravitational waves we've seen from black holes, which is amazing, and I would never have bet we'd really be able to do it. The experimentalists, I thought that was a lost cause, but they will do it. But eventually, we may be able to detect gravitational waves from the beginning of time itself, from a process called inflation. And if we can do that, we can probe almost the earliest moments of the universe. And even though if there is a multiverse, other universes that we can't directly see, we might indirectly be able to prove they exist by understanding the nature of inflation. And that would turn sort of metaphysics into physics. So I think that will profoundly affect our understanding of the universe, and allow us to do something maybe, which again, I might have thought would be impossible, which is to know if our universe is unique. It's not clear we'll be able to detect gravitational waves from inflation. It's not clear that we're not guaranteed to be able to do that, but if we can, it'll be incredibly exciting. So those are two things that sort of drive my wish list, because I'd like to know if the universe is unique, and I'd like to understand why empty space has energy. So I think that answered the question. I forget what the second part of the question was, but
no, it is. It is. You did one current and then one possible. Yeah, you covered the question.
okay,
So
good.
there's two things left, because one, I know that you're going on tour soon, on a lecture tour soon. So we're going to cover that in just a second. But the last question that I have for you before that is, what do you want your legacy to be? What is it that you would like people to remember about you, or what you have left behind for them to learn? If you can answer, and I wanted to put pressure and be like, answer it in 30 seconds. No, I'm just kidding. But you can take your time if you have something.
I don't really care. I mean, my legacy is not up to me, and I know what I know what I think is important that I've done, but it probably is beyond my control about what people think or don't think about me. I like, I just got a lovely letter from a young man whose life I apparently changed years ago and is now a scientist. I'd like, I'm happy with the work I've done to try and understand the universe, and I'm equally happy with the work I've done to try and communicate that excitement and help people understand the universe and be excited about it. Which of those things, or either of those things, or neither of those things that people choose to attach to my name after I'm gone is I won't be around to worry about it. And I think it's presumptuous of me to imagine that. We all have hopes about things, but you do what you do, and the rest is out of your control, I think. And
so to close out, then let's talk about the lecture tour. What is this lecture tour, and who are you going on tour with?
well,
So
let me,
who are you
let me
going on
give you
tour?
there's two lecture sets of events that are really kind of exciting, live lectures. One is my foundation, which runs the podcast I do, and there's going to be some big new developments there that we'll announce in the next month or so. But my foundation is finally having its first live events. We planned them years ago, but then COVID got in the way. So the first live events will be in Phoenix, which is where I used to do some live events, although we'll eventually do them around the world. And they're quite exciting. And I think I can say, because we're going to announce in a week or so what they are, but one event, they'll be in April 10th and 11th. And I believe April 10th will be a 10th anniversary showing of the Unbelievers film with me and Richard Dawkins on stage, with some new footage from a number of the people who contributed to the movie. And that'll be April 10th in Phoenix at the Orpheum Theater. And then April 11th, and this will be relevant to the questions your audience just asked, we will have the 6 of the world's most well-known cosmologists on stage at the Orpheum Theater in Phoenix, talking about the future of cosmology and the open, outstanding questions. And right now, I believe I can't finalize this, but the current attendees will be Andrea Ghez, who won the Nobel Prize a few years ago for her work on black holes; Barry Barish, who won the Nobel Prize for his work on gravitational waves; Lord Martin Rees, who people may know as the Astronomer Royal and the President of the Royal Society; Robert Kirshner, who studied supernova, and both of whose students actually won the Nobel Prize for the discovery of dark energy. I hope Wendy Friedman, who was one of the leaders of the Hubble Space Telescope project, and Michael Turner, a colleague of mine, who's two theoretical physicists, Michael Turner and Joe Silk, 2 eminent cosmologists. So it's a big lineup, and I'm hoping they'll all be on stage, and that'll be April 11th. Now, both of those will be filmed and later on will be broadcast, but I encourage those who might be in the Phoenix area to consider coming. I think tickets will go on sale March 1st. Now, the other lecture tour is in Canada, and it's a lecture tour, parts of with Sabina Hassenfelder, who some people may know is a scientist, a physicist, and she's a science communicator. And she and I will be doing an event in Montreal, April 12th, the day after the event I do in Phoenix, and then in Calgary, I believe April 13th, and then with another gentleman who's an online science communicator, an event. Sabina and I will be doing an event. All 3 of us will be doing an event in Vancouver. Also tentatively on the schedule are potentially 2 events for Toronto and Ottawa, which will be later, perhaps in May. And tentatively, I may be doing them with my friend Penn Gillette. So stay tuned for those. But April 12th, 13th, and 14th. And you can, and so as far as the Origins events, go to Origins Foundation, originsprojectfoundation.org. Online, and you'll be able to see when those events are, and through there you'll be able to get tickets. And then for the Canadian tour, you can go to I think it's Pangburn I should know, but I think it's pangburn.com, pang-burn.com/tickets, pang/burn.com/tickets.
I appreciate that. Dr. Krauss, it has been an honor having you on today. Thank you. And by the way, guys, if you have missed anything we've talked about, any of the questions, don't worry about it. This will be up now permanently on YouTube. Also, I have all of the links that Dr. Krauss has been talking about to his books, to his websites, his tours. All of that will be linked in the description box below. And you can also reach Dr. Krauss on Twitter at lkraus1 on Twitter. Dr. Krauss, thank you so much.
Oh, it's actually a pleasure to talk to you. I could even tell you that cosmology joke if you want to now, but it's okay.
Absolutely. Before I wrap up, go ahead.
Yeah, since it's relevant, it's someone like me says that, the sun is gonna end its lifetime in about 5 billion years and encompass the Earth. And someone like you, but not you, someone he's talking to said, "Did you say 5 million years?" And the guy like me says, "No, 5 billion years." And the guy goes, "Okay." Anyway, it's not a great joke, but it's relevant to what we were talking about, the long time frames of the future. Anyway, it was fun to talk to you.
Absolutely. So my guest today has been theoretical physicist and cosmologist and author, Dr. Lawrence Krauss. I am your host, Pat Voss, for this Golden Knowledge podcast. We will see you next Friday for Richard Carrier and the historicity of Jesus. Have a good night.
Take care.